Okay, so for slope, when we're talking about, and again, like I said, slope is the same thing as constant rate of change. When I say I can find the slope of a graph, table, word problem, or between 2 points, I am relating it to a constant rate of change. That slope is telling me a rise over a run. Your rise in this situation, when we talk about the rise, that's the change of your y. So go ahead and circle rise and put that that's your change of y. And then your run is your change of your x. So when we were going over constant rate of change, I told you that it's also known as slope. Now we're showing it to you as the slope. So when we are talking about, so the rise, again, like I said, that was what our value of change of y was. Remember, our change of y would always go on the top of our constant rate of change, and then the change of our x, which is our run, that was always going to go on the bottom of our constant rate of change. So we just put it as rise over run, okay, which is easy to remember because rise represents for the y. How many legs does a y have? Like, how many legs does y stand on? One, right? So y only has one leg, so all it can do is just jump up and down. How many legs does x have? Two, so it can run. Okay, so it's easy to be able to remember that y has one leg, it rises up and down, it jumps up and down. X has two legs, all it does is run, so it runs left and right. Okay, so a couple of things that you need to make sure you are aware of. Slope is mainly going to be presented as a fraction. Every so often they might give it to you in decimal form, but you will convert it to a fraction. So I want to make sure you guys understand that that slope is mainly presented as a fraction. And also something that you need to make sure you will always leave them alone as improper. You will never convert them into a mixed number. If they are improper, you leave them alone, you let them stay improper fractions. Okay, because again, your slope is a single value of rise over run. It's not a whole number in rise over run. It's just rise over run. So if you have an improper fraction, that is okay. You're no longer thinking of them as fractional values. You're thinking of them as directions. So that's the second thing I wanted to make sure you understand. That slope is direction from one point to the next. It is telling you, hey, from point A to point B, you're going to go to go down 3 points and then go to the right 2 points. It's letting you know the direction that you're going to proceed in order to get from point A to point B. Okay, now slope is not always just going to be presented to you in a graph or in a table or in a context. Sometimes it might just be actual word problems that you're being presented with. So here, treadmills. Treadmills are a very common way of utilizing slope, right? We use inclines. So if you want to have a more difficult treadmill experience, you're going to raise the incline as much as you can. It makes it a lot harder. It kind of gives it an idea of like you're walking uphill, okay, which takes a little bit more endurance to be able to do. So a treadmill is a great example of how slope is utilized. So here, the treadmill extends 30 inches in its width, and it has an 18-inch incline. So we want to know the slope. So which one of these values would represent the rise, the 30-inch width or the 18-inch incline? Elijah, 18-inch incline. So we're going to go ahead and underline that or highlight that in our blue. That's going to represent the rise of 18. That means that the 30-inch width is going to be our run. Okay, so again, we present it as a fraction. We got 18 over 30. Now, you can still simplify. You must still simplify when you're given your fractions. Your slope needs to be in its simplest form. Again, it's okay for it to be improper, but it still needs to be simplified. both 18 and 30 happen to be divisible by what value? What's the largest common factor that they share? Eker? 6. Okay, so they both can be divided by the value of 6. That means we have a slope of 3/5. Go ahead and do number 2 on your own. Okay, so what's the slope going to be for the hiking trail? 3 over what?
50.
3 over 50. Okay, so we have 3 over 50. If we're taking a look here, it tells us explicitly that it has a rise of 6. And that our horizontal change, every horizontal change is 100 feet. So our run is going to be 100. Again, both of these happen to be divisible by 2. So that means it's going to come out to 3 over 50. All right, now running over this again, the types of slope, the different types of slope that we were showcased on our Slope Dude video. Who can recall what was the slope for this first graph? Raise your hand and let me know what was the slope called for this very first graph.
Like what they said when they went up.
Well, you don't have to say what they said, but what is the type of slope called at least? Positive, puff plus positive, right? When you're going uphill, when you're walking uphill, it takes a little bit more effort. It kind of might make you worn out. It's a little bit difficult, but you're going up and you're puffing along. It's puff, puff, positive. Okay, what about this second graph, the one I'm highlighting in pink? That was our what? Negative. Nice, negative, right? It's easy going. Nice, negative. Okay, and then our flat surface right here, 0, right? This is 0 fun. This is 0 fun. And then, of course, our favorite math curse word, undefined. Oh my gosh, she said the bad word. Okay, so it is our undefined graph. Now, here is the reasoning as to why these two come out to 0 and undefined. So taking a look here, I'm going to grab my calculator for a moment. Okay, for this very first graph, I could pick any point that I'm going on. Like if I go to x equaling -4, y is going to be a positive 5. And if I go to x is equaling positive 4, y is still negative 5. So my x is changing, isn't it? My x keeps changing, but my y never changes. My y stays at a change of 0. So that means that I'm having a fraction of 0 over some value. So I can pick any value. If I go from -4 to positive 4, that was a change of 8. So 0 over 8, when I hit enter, it's going to come out to 0. So if your x is able to have a change, but your y stays consistently no change, that creates a 0 value. Your undefined, your x is not changing. So your x change is 0 because you're staying in one spot for all of your x's, but your y is changing, right? You're going from one point up to the next, up to the next, up to the next. So your y shows a change. So again, I can show this as, let's say the change was 5 for my y over no change at all for my x because it's a vertical line. I'm going to get a divide by 0 error. When you get an error, that's why we call it undefined. It's impossible to have 0 value for your fraction. You're not allowed to have 0 as a denominator. So it creates an undefined value. Okay? The reason this is called positive value because as you are going up, you are also going to the right. So every single time as you are going up, you are going to the right. So that means that you have a positive value and a positive value, which is going to equal a positive value. Or the direct opposite. If you are going down, then you're moving also to the left. As you're moving down, you're moving to the left. That means you have a negative value and a negative value. A negative times a negative is also going to equal a positive. Okay, so you have to think about those integer values, that when you're multiplying them, if I multiply a positive times a positive, I'm going to get a positive. If I take a negative times a negative, I'm going to get a positive. Okay, and then for your negative value, it has a direct opposite effect. If we are going up, we are going to the left. So that means we're taking a positive and multiplying it by a negative. That's going to equal a negative value. As we are going down, we're moving to the right. So we're taking a negative and a positive, and that creates a negative. So these are what's creating your negative values. And again, the zero slope meant that you had some number on the bottom for your change and 0 at the top. 0 over a number is going to equal 0. If you have a number, oops, sorry, this should be an orange. If you have a number over 0, that's going to equal an error. So that creates that undefined value. All right, get that written down and go ahead and flip the paper on over to the back. Sorry. I didn't do that. I didn't sing it.
I'm such a deputy, bro. So you haven't been writing it down when she wrote it down?
No, he hasn't. All right, let's continue on. So for here, we're now looking at our slopes graphically. Obviously, we know that this is going to be what type of slope? Negative. So it's always a good idea before you start finding the exact slope is just identifying the type. If I know that the type is going to be negative, then I can eliminate a couple of answer choices when I'm looking at some problems. So the next thing that you need to do is you need to pick a couple of points on your graph. It doesn't matter which points you pick, but you must pick 2. And they must pass perfectly on the grid. So where the grids intersect is where you want it to pass on a line. So here's a perfect point located at 0, 3. And then here's another perfect point located at 2, 0. There happens to be another perfect point right here located at 4, negative 3. You could use any one of those 2 points, okay? So in fact, I'm going to show you saying, hey, if I were to use just the 2 points next to each other versus 2 points that are not next to each other, it's still going to simplify to the same one. So let's take a look at the very first point all the way to the last point. When I'm looking at this graph, I need to make sure that I'm counting intervals, because sometimes your grid doesn't count as an interval. Sometimes your grid is not going to count as an interval. DJ, I don't know why you're on your computer, but go ahead and close it. Okay. So in this case, yes, every single interval counts as one box, but there are some times when an interval box, like a box might count as 5, intervals or 7 intervals. So you need to make sure that you're looking at the numbers, not just the boxes. But here we're going 1, 2, 3, 4, 5, 6 positions down. 6 positions down indicates that this is going to be a negative 6 for our rise. Okay, then we need to do the run. Our run from this point where we just stopped with our rise, we're going to go to the right. 1, 2, 3, 4. So we're going 4 spots to the right. That makes it a positive 4. So our run is a positive 4. Okay, so we have a negative 6 over a positive 4. Remember, a negative over a positive is going to give us a negative. Please note that I'm not assigning that negative sign to either one of those numbers. I'm indicating that the slope itself is negative. What that means is that 3 could be negative or 2 could be negative, and it's perfectly fine. Both of them are not negative at the same time. Only one is negative. So you put it out in the front so that way it doesn't confuse you thinking that 3 is always going to be the negative or that 2 is always going to be the negative. What this means, if the 3 was the negative, that means you would be going down 3 and then to the right positive 2. Or if the 3 was positive, that means you'd be going up 3. That would make the 2 negative, so you'd be going left 2. Okay, so it lets you know, again, I told you before, slope is direction. Slope is direction. It tells you how far up and down you might go, how far left and right you might go, based off of positivity or negativity. Okay, and like I said before, it doesn't matter which points you're picking. If I were to pick these 2 points that are close to each other, let's say I start, and you always start from left to right. Always work from left to right. So if I'm starting here, from this point, I would be going 1, 2, 3. That's 3 down, -3. And then 1, 2 to the right, that's +2. So -3 over +2 is -3 over 2. Okay, it comes out to the same thing. It doesn't matter which one you choose to do. Okay, go ahead and do number 4 on your own. You can raise your hand, tell me what they got for the slope for problem number 4. How about somebody for the row 3? Nobody in row 3 has answered. I'm going to call on James, what did you get for number 4?
I got 2 over 3.
2 over 3 is correct. No, 2 over 3 is correct.
Yeah.
Go with your gut. 2 over 3. All right, let's take a look. Shh. It is a positive slope. It is moving upward, uphill, so it makes it a positive slope. You have a rise, so I chose these 2 points, but it could be any points that you chose. It doesn't matter as long as you get 2 over 3 at the end. I had a rise of 4 and a run of 6. A rise of 4 and a run of 6. Positive 4 over positive 6 gives me 2/3. Now again, what this means is that both numbers are moving in a positive direction, or both numbers could move in a negative direction. Okay, so both numbers would be going negatively or both numbers would be going positively. They both would create a positive slope no matter what. Okay, problem 5, what was problem 5? Come on guys, say it out loud.
Undefined.
Undefined. 6 was 0. Okay, those are ones from direct from the pictures. If it's a vertical line, it's undefined. If it's a horizontal line, it is 0 slope. All right, go ahead and go to the last page. Okay, Jamez, since you came in late, it'd probably be wise of you to not be turning around and talking to somebody. Okay. All right, let's take a look at table formats, finding our rise and runs from a table. It is no different than doing constant rate of change. Instead of calling it change of y and change of x, you're just saying, hey, this is our rise and this is our run. Okay, so our rise in this case seems to be going down. We're decreasing by -3 from each one of these points. And then our run, we are increasing by 2 for each one of these points. So when we are writing out our rise over our run, our rise was a -3. Our run was a +2. So then when we write this as just a fraction without the positive and negatives attached to numbers, we would have a -3/2. Okay, you just need to make sure that you are careful about positions, especially with these horizontal tables. A lot of times people mess up by putting it run over rise. It needs to be rise over run. Go ahead and do number 8. Eager is very eager. Let's take a look here. Our rise, again, it's the change for your y. So in this case, we're going from -2 to a -1. That means we're increasing by 1. But then we're going from -1 to +1. That was an increase by 2. And then 1 to 2 is an increase by 1, which is okay for that to happen, remember, because they will come out to the same value in the end. Our run, when we went from -6 to a -2, we increased by 4. -2 to a +6 was an increase by 8, and then 6 to 10 was an increase by 4. So again, when we're looking at our rise values, we had a 1, but we also had a 2. When we look at our run values, we had a +4, but we also had a +8. Those all are going to simplify to the exact same value of just 1/4. So there is your slope, 1/4. Okay, do not switch it. Be careful. All right, now slope formula. Slope formula, sometimes you are given 2 points, but you are not given it on a graph. You are just told, here are your 2 points. So when you're told your 2 points, we typically just say, okay, I'm going to assign that first point that I see as a x1 and my y1. And then I'm going to let the second point that I see be my x2 and my y2. So I'm just assigning them that this is my first point, this is my second point. That's all I'm doing. When you are doing your slope formula, order matters. The order that you are doing this matters. You cannot just randomly assign different orders. You will get it wrong. Okay? So when you're doing your slope, it is a subtraction problem on both the top and the bottom. On the top, you are subtracting your y's. We always say that we take the second point of y and subtract the first point for y. So we do y2 minus y1. For the denominator, it's our change of x's, right? So it's our x2 minus our x1. Okay, and then we just simplify if need be. So taking a look here at problem number 9, this is my first point, 1, 2. So this is my x1 and my y1. The second point is going to be my x2 and my y2. So then I just substitute them back into this formula. Guys, get used to doing this. Create a fraction bar, create your subtraction signs, and then fill in your information. The reason I say that is because the biggest mistake students make is they see that they are subtracting a negative and they drop one of the signs. They're just like, oh, my second point or the first point has like a -7, so I'm just going to put -7 because minus is a negative. But it's not. It's minus whatever the value is of that point. So you might be doing minus a -7. Okay? Do not drop your negatives. So for here, again, I'm filling in my y2 minus my y1. My y2 value is a -3. My y1 value is a +2. For my denominator, I'm doing x2 minus x1. So my x2 value is -4. My x1 value is a +1. So now that I have it positioned and I've filled in all the values in there, I can start subtracting. So I do -3 minus 2, that's going to come out to a -5. When I do -4 minus 1, I get -5. So now I have -5 over -5, that comes out to a +1. So my slope is 1. Okay, I'm going to do the last one with you again. I'm very proud of you, but don't be cocky, okay? All right, so for here, we have our first point. This is my x1, this is my y1. Here's my x2, my y2. Substituting it into my formula where I'm going to subtract on top and on bottom. I focus on the y's first. What's my y2 value? -2. What's my y1 value? -4. Do you have a question or?
Somebody gave the American card.
Huh?
Someone thanked the American card on the floor.
Okay, hand it to me.
It's mine. What are you talking about, bro? It's
Yo,
literally mine.
he had it in the morning.
Does it say your name on it?
This is my grandpa's name. Bro, what is your grandpa's name again?
Background check.
It's Harry L. Flood.
Okay, if it says flood on it, then it's... All right, shh, come on, take a word. Let's continue. What's our x2 value? -3. Our x1 value is -7. So now we're going to go ahead and do our subtraction. -2 minus -4 comes out to a +2. -3 minus -7 comes out to a +4. And then 2 over 4 can simplify to 1 over 2. You have a Delta Math that is loaded in Google Classroom.
Get out!
No, you get out.